Solving systems of equations using eliminations. More examples. Starting with the word problem. You brought back lunch for some friends. You've still got an off-campus pass because you follow the rules. You spent $13.50. You bought 5 items. 3 of them were tacos that cost $1.50 each. And then, there were some items that were tacos that cost $1.50 each and burritos that cost $3.50 each. How many burritos did you buy? So this time, remember I said sometimes they're going to ask you for all the answers, and sometimes they're just going to ask you for the answers to one. So we're dealing with tacos and burritos. Tacos are $1.50. Burritos are $3.50. Ooh, decimals, yuck. And there's a couple different totals. We've got total money of $13.50 and total items of 5. Okay, so this is very similar to the last one. We'll make sure we get some different examples in there, but these examples are really common. This stuff comes up all the time. We're dealing with items and we're dealing with money. Items, we know we have a total of 5. That's not where that should go. We know we have a total of 5. And money, we know we have a total of $13.50. Our items that are going to add up to 5, again, I'm just going to call them X and Y. But now it's going to be super important that I know which is which. I'm going to use X for tacos and Y for burritos. Okay, so this is going to be, in fact, I'm going to put that 2 places because I know I'm inclined to forget. Tacos and burritos. Okay, not pretty, but it's there. So tacos we said are $1.50 each, and burritos are $3.50 each. Now that's kind of an ugly second equation to deal with. Can I make it a little prettier? Yes, I can. Again, I don't want to mess with my original equation. I'll put my box around them, keep them safe before I start trying to do stuff. But I can make that second equation a little prettier. I can move the decimals. So I'm going to write it again. If this was my homework, I might not write it again like this, but if these are my notes, I'm going to write it again so I know what I was talking about. Because if this is my equation, I can do that, and do that. Now, do I really need to make it $13.50? No, because I don't need that last 0. I can divide everything by 10, right? Let's say that a different way, because I bet I just lost some people. Okay, I don't need this 0. I don't need this 0. I don't need this 0. I have 13.5. That's what it means to be $13.50, right? I have 1.5. That's what it means to be $1.50. I have 3.5. That's what it means to be $3.50. So I really just need to move this once. And that'll keep things a lot smaller. So my equation is 135 equals 15x plus 35y. Much prettier. And then as I bring my second equation down now, I want to multiply by the smallest thing I can. So I'm going to multiply by -15. That's what'll get that x to eliminate. I would honestly do this one with substitution if I was doing it, but I know you guys, you're going to try to use elimination, so we'll do it with elimination. So I've got to multiply by 15 times 5 is 75. So -75, -15x, and -15y. So we multiplied 5 equals x plus y, all positive. We multiplied by 15, negative, all the signs are negative, everything is 15 times bigger. Okay, so these guys go away, and I have 20y equals 60. See, not bad math at all. So y is 3. Okay, now is y what we wanted? We wanted burritos. They only care about the burritos. So how many burritos did you buy? I bought 3 burritos. Should I really stop there? No, quickly I'm going to check and make sure that was right. I'm just going to do a verbal check. Let's see. If I bought 3 burritos, that means I bought 2 tacos. 2 tacos would be $3. 3 burritos would be $10.50, right? $3.50, $3.50, $3.50. And $10.50 plus $3 is $13.50. So I am good. 3 burritos is the answer. Next example. 4x minus 2, that's not a 2, that's a 10y equals 18, and negative 2x plus 5y equals negative 9. There's my original equations. And what can I multiply by to get something to drop out? Let's see, my signs are negative on my x's. I can multiply the bottom one by 2. That looks pretty painless, so I'll do that. I could also, I could also multiply the bottom one by 2. Oh, both my x's and y's are going to drop out. So if I multiply the bottom one, I get negative 4x. 2 times 5 is 10y. 2 times negative 9 is negative 18. And then I bring the top equation down. Everything goes away. Well, what do I have left? I have 0 equals 0. How do I know if that means no solution or infinitely many? It's a true statement. If I have a true statement, then it's infinitely many. Those are the same equations. Same, if I put them in slope-intercept, it would be exactly the same thing. So any point that's on one line is on the other. Anything that's a solution to one is a solution to the other. They're the same line. If I graphed one and graphed the other, one would be right on top of each other. Okay, another example. 4x minus 3y equals 8. Negative 8x plus 6y equals 16. So it looks like I can multiply the top one by 2. That looks pretty painless. If I do that, I've got 8x, 2 times negative 3, negative 6y, 2 times 8, 16. Bring the other one down exactly as is. Negative 8x plus 6y equals 16. Some of you are thinking, it's the same thing. No, because this time these don't drop out. Do I have a true statement this time? No, I have a false statement. 0 is not equal to 32. So that's when it's no solution. As long as you keep it associated with true, false, it's pretty easy. So those are the extra examples. You should be in good shape.